Have you ever looked up at the night sky and wondered what else is out there? Beyond the familiar glow of the moon and the twinkling points of light that are distant planets, our solar system holds many secrets. One of the biggest and most spread out features is the asteroid belt. It's a vast, donut-shaped region filled with millions of space rocks, all silently orbiting the sun. But what if they weren't so silent? What if, by some cosmic magic, all those individual rocks and boulders came together? Imagine a new planet suddenly appearing in our solar system. This isn't just a fun idea from a science fiction movie. It's a fascinating thought experiment that helps us understand how our cosmic neighborhood works. Let's embark on a journey of scientific imagination. This grand question, what if the asteroid belt became a planet, opens up a universe of possibilities. It forces us to think about the very rules that govern our solar system. How are planets born? What keeps them in their neat, predictable paths around the sun? To understand what it would take to build a new planet, we first need to visit the construction site, the asteroid belt. Imagine our solar system as a giant racetrack. The asteroid belt exists in the huge gap between the inner, rocky planets and the outer, gassy ones. It's not a crowded, dense field like you see in movies. Instead, it's an enormous, mostly empty region where these space rocks are often millions of kilometers apart. The biggest resident of the belt is a dwarf planet named Ceres, which is nearly 940 kilometers in diameter, big enough to be spherical. But most asteroids are much smaller, ranging from the size of a large city down to the size of a pebble or a grain of dust. These are not just plain gray rocks either. They are ancient relics from the dawn of the solar system, about 4.6 billion years old. Some are made of clay and silicate rock, while others are rich in metals like iron and nickel, and some even contain frozen water and organic compounds, the building blocks of life. So why is there a belt of rubble here instead of a planet? The main reason is a giant gravitational bully named Jupiter. In the early days of the solar system, when planets were forming, Jupiter's immense gravity stirred up this region. It was like a giant cosmic blender. Despite containing millions of objects, the total mass of the asteroid belt is surprisingly small. If you were to gather up every single asteroid and squish them all together, the resulting object would have a total mass of only about 4% of our moon's mass. It would be a much smaller, but still fascinating planetary body, a cosmic underdog in a system of giants. So, how does the universe bake a planet in the first place? It's a process that takes millions of years and follows a specific recipe, starting with a giant cloud of gas and dust. This cloud, called a solar nebula, begins to collapse under its own gravity. As it collapses, it spins faster and faster, just like an ice skater pulling their arms in. Most of the material gets pulled to the center, getting hotter and denser until it ignites to form a star, in our case, the sun. The leftover material forms a flat, spinning disk around the newborn star, known as a protoplanetary disk. This disk is the cosmic pantry from which planets are made. Within this spinning disk, tiny dust grains start to stick together. At first, it's just static electricity like dust bunnies forming under your bed. Little specks clump into slightly bigger specks. But as these clumps grow larger, something more powerful takes over. Gravity. Once a clump gets to be about 1 kilometer wide, its own gravitational pull becomes strong enough to start attracting other nearby clumps. These kilometer-sized bodies are called planetesimals, the basic building blocks of planets. They are like cosmic Lego bricks, and the next stage of planet formation is all about getting them to connect. It's a messy, chaotic process of collision and accretion. This stage is a bit like a demolition derby in space. Over millions of years, the biggest planetesimals grow bigger and bigger, sweeping up all the smaller material in their orbital path. Their gravity becomes so dominant that they become the gravitational kings of their neighborhood. For the asteroid belt, this process was violently interrupted. Jupiter's gravity was the great disruptor, preventing the planetesimals from ever getting the peace and quiet they needed to accrete. To overcome Jupiter's interference and finally form a planet from the asteroid belt, we would need to introduce a new, powerful force into the equation. Perhaps a rogue star passes near our solar system, temporarily nullifying Jupiter's influence. Or maybe some unknown advanced technology is deployed to gently nudge the asteroids together. Whatever the cause, the first step would be to slow down the asteroids. Right now, They are zipping around the sun at high speeds, and when they collide, they shatter. We would need to reduce their relative velocities so that when they meet, it's more of a gentle cosmic hug than a catastrophic explosion. With the asteroid slowed down, the process of accretion could finally begin as intended. The largest object, the dwarf planet Ceres, would likely become the seed for this new world. As it consumes them, its mass and gravitational pull would increase, making it even better at attracting more distant material. This would trigger a runaway effect. This process would be incredibly violent and spectacular. For thousands of years, the sky of Ceres Major would be filled with fiery streaks as millions of asteroids, large and small, rained down upon its surface. Each impact would release a tremendous amount of energy, melting the surface and contributing to a global magma ocean. The planet would glow with the intense heat of its own formation. Over time, as the bombardment slowed, the heavier materials like iron and nickel from the metallic asteroids would sink towards the center. This process, called differentiation, would form a dense metallic core. Eventually, the molten surface would slowly cool and solidify, forming a solid, cratered crust. The final result would be a brand new spherical world, born from the fire and fury of cosmic collisions. The age of Beltania would have begun. Now that our planet, Beltania, has formed, what would it actually be like? Let's start with its size. This means Beltania would be a very small world, a mini-planet of sorts. Its diameter would likely be just over 1,000 kilometers. Its tiny size means it would have very weak gravity, less than a 20th of Earth's pull. The composition of Beltania would be a fascinating mix of all the different types of asteroids that formed it. It would have a dense core of iron and nickel, surrounded by a thick mantle made of silicate rock, just like Earth's. The crust would likely be a mixture of rock and, importantly, water ice. During its hot, molten formation, much of this water would have been baked out into a temporary atmosphere, which would have then frozen and fallen as snow. Beltania would settle into a stable path around the sun, right in the middle of where the asteroid belt used to be, at a distance of about 2.8 astronomical units. Because it would be so far from the sun, its surface would be incredibly cold, with average temperatures likely plummeting to around -100 degrees Celsius, or even lower. It would be a frozen, barren desert world, locked in a deep freeze. Given its small size and weak gravity, Beltania would not be able to hold on to a significant atmosphere. Without an atmosphere, there would be no air to breathe, no weather to speak of, and no protection from the harsh radiation of space. The surface would be a silent, pockmarked landscape, covered in craters from its violent birth, and from subsequent impacts over millions of years, a testament to its chaotic origins. The sudden appearance of a new planetary body, even a small one like Beltania, would send gravitational ripples throughout the solar system, fundamentally altering the cosmic dance of the planets. Introducing Beltania would be like adding a new heavy dancer onto a finely balanced stage. The first to feel the effects would be its closest neighbors, Mars on the inside and the colossal Jupiter on the outside. Mars, being smaller and closer, would be more significantly affected. A more eccentric orbit would mean more extreme seasons with hotter summers and colder winters. For a planet that we dream of one day colonizing, such a change could make it an even more challenging environment. Jupiter, the king of the solar system, would also feel the pull, but its immense mass means it would be far less affected. It would be like a giant bowling ball being nudged by a marble. For eons, Jupiter has acted as a gravitational shield, its powerful gravity deflecting many comets and asteroids that might otherwise be on a collision course with Earth. With Beltania now in the mix, the complex gravitational interactions would change. Beyond its immediate neighbors, the gravitational influence of Beltania would propagate outwards, subtly tweaking the orbits of Saturn, Uranus, and Neptune. However, the solar system is a chaotic system, meaning that tiny changes can sometimes lead to unexpectedly large consequences over very long timescales. The cosmic dance would have a new partner, and the choreography would never be the same again. While Beltania would be millions of kilometers away, its birth would not go unnoticed here on Earth. Our planet is part of the same interconnected gravitational web, and a change this significant would inevitably have consequences for us. The most immediate effect would be the complete removal of the main asteroid belt. This would be a major change for planetary defense. However, the period of Beltania's formation would be an incredibly dangerous time for the inner solar system. The process of accreting millions of asteroids is not a neat one. It would be like a cosmic food fight, with rocks being thrown in every direction. The inner solar system, including Earth's orbital path, would likely see a massive increase in the number of rogue asteroids. This heavy bombardment period could last for thousands of years, dramatically increasing the risk of a catastrophic impact event. Even after Beltania has settled into its stable orbit, its gravitational tug would be felt by Earth. Our planet's orbit around the Sun could be subtly altered. A tiny change in our distance from the Sun or the shape of our orbit could have significant long-term effects on our climate. It might nudge us towards a warmer period or push us into a new ice age over geological timescales. Furthermore, the night sky would be forever changed. A new, bright point of light would be visible to the naked eye. Beltania would appear as a bright, star-like object, moving slowly across the constellations from night to night. For humanity as a whole, it would be a constant, visible reminder that our place in the universe is not static. It would challenge our mythologies, our sciences, and our sense of security, proving that the cosmos is still a place of profound and unexpected transformation. The creation of Beltania would revolutionize the future of space exploration, presenting both incredible opportunities and new challenges. This new world would instantly become the most fascinating and accessible destination in the solar system beyond Mars. Scientists would be desperate to land on its surface to study its geology. By analyzing its crust and mantle, we could learn firsthand about the composition of the primordial solar system. Beltania's low gravity would make it an ideal staging post for missions to the outer solar system. On Beltania, with its gentle gravitational pull, spacecraft could land and launch with relative ease. It could become a cosmic refueling station. We could mine this ice and split it into hydrogen and oxygen, the two primary components of rocket fuel. A base on Beltania could serve as a gas station for spacecraft heading to Jupiter, Saturn, and beyond. The planet would also be a treasure trove of valuable resources. Since Beltania formed from these very asteroids, these materials would be incorporated into its structure, with its crust far richer in these elements than Earth's crust. Mining operations on Beltania could provide the resources needed to build vast space habitats and further expand humanity's presence throughout the solar system. It could fuel a new, off-world industrial revolution. However, exploring and colonizing Beltania would present unique challenges. Its lack of atmosphere means there is no protection from solar radiation or micrometeorite impacts, requiring heavily shielded habitats. The very low gravity could have serious long-term health effects on human colonists. Future explorers would need to live in rotating habitats to simulate gravity. Beltania would be a frontier world in every sense, a place of immense promise and profound danger. In the end, the transformation of the asteroid belt into a new planet, Beltania, is more than just a fun scientific what if. It's a profound exploration of the forces that shape our universe. It reminds us that the solar system we see today is just one possible outcome of a chaotic and dynamic history. For every planet that formed, there are countless stories of worlds that almost were. This thought experiment highlights the interconnectedness of everything in our solar system. No planet is an island. The gravitational pull of Jupiter had a direct impact on the potential for a planet to form where the asteroid belt is. It's a beautiful, complex dance, and we are just beginning to understand the steps. Imagining a remixed solar system forces us to look at the familiar planets as members of a dynamic family, constantly influencing one another. Thinking about Beltania also fuels our collective imagination and our drive to explore. The greatest leaps in science and technology often begin with a simple question that challenges the status quo. These questions push us to build better telescopes, design faster spacecraft, and dream bigger dreams. The story of Beltania represents the potential for discovery that lies hidden in the seemingly empty spaces of our cosmos. So the next time you look up at the night sky, take a moment to peer into the darkness between Mars and Jupiter. In that empty-looking patch of space lies the ghost of a planet, a sprawling field of cosmic debris that tells a story of what might have been. The very idea of Beltania serves as a powerful reminder. It tells us that our universe is not a finished painting, but a constantly evolving masterpiece, full of untold stories and mind-blowing possibilities, just waiting for a curious mind to ask, what if? The adventure of science is truly endless.